Okay, guys, welcome to Caleb and Roman's. Here, Roman, do over here. Caleb and Roman's chemistry party, winter quarter 2020. During the course of this quarter, we hope to not only instill you with a deep, almost overwhelming love for chemistry, but hopefully we'll actually perform the labs correctly too. And that's our horrible segue into our first lab, fractional and simple distillations. When you think of distillations, right, we think of our favorite alcoholic beverage, which, yeah, well, Roman's favorite alcoholic beverage. I'm under 21. I would never have. But there's two types of distillations, right? We got fractional and we got simple. I'll start out explaining simple. Simple, as the name implies, is relatively simple. You take a mixture of two liquids, could be more, could be, well, actually, it can't be less. It has to be two or more. Two or more. Take two or more liquids and you put it in a combined flask and you heat the flask. And the goal is that these two liquids have distinct enough boiling points that one of them will rise in vapor phase, condense in the condensing tube, and collect in that little chamber there, while the other liquid, or variety of liquids, remains in the original chamber. And thus you pretty simply distill out one from the other. So like, I don't know, it could be water and ethanol. Ethanol boils at like 79 degrees Celsius, while water boils at 100. So if you set it at, like 79 degrees Celsius, you'll get ethanol in the container and you'll have water remaining there. Yeah. On the other side, fractional distillation is a little bit more complicated, but it's actually not. It's basically just a whole bunch of micro simple distillations all happening in what's called a condensing column. No.
Yeah. Vigorous column.
The vigorous column, yes. Excuse me. Yeah, so you have multiple liquids in the original chamber, and you apply heat to it. And what happens is in this column, you have a whole bunch of hacking.
Yeah.
It could be where in our case we're using.
So we're using like a tube or condenser with different cross sections of glass inside. So what happens is like first it will go hit there, comes down. If it has more energy, then it will go up and then hit and also come down. So it's just like having more of those weird surfaces in the condenser. Like it will basically help us separate those two liquids very easily.
Exactly. Yeah. So yeah, if you want a really complex explanation, you can go talk to Dr. Sandra Eaton. And get the full thermodynamics, as Roman and I we were given that explanation. Is very difficult. But the easiest way to think about it, right, is it's just a whole bunch of small, simple distillations. So the liquid evaporates and it condenses onto one of the pieces of the packing column. It re-vaporizes and recondenses. And graphically, this is showed on the graph of temperature versus mole fraction. I'm just assuming we have a 2. That's a 2. That's a 2. We have two species here. So we got a mole fraction. A mole fraction of 0.5 means you have 50% component A and 50% component B. And basically how it works, right, is here you got the vapor phase, and here you got the liquid phase. And what happens is you get like this ping pong of vaporizations and condensations throughout the whole thing. So you get the diagram that looks sort of like this, with that being the condensation and that being the vaporization. And so all of these micro vaporizations and condensations are all happening inside the condensing tube, which works to drive the mole fraction towards one side or the other. Like in our example here, we're driving it towards boiling point B, and so we'll be collecting a lot of a lot of component B in our collection tube. But you could just as easily send it the other direction. And this is basically what we're doing. For the first couple of weeks, we'll just be, okay, OChem 2 lab I think is a little weird because you start out just learning a whole bunch of techniques. It's technique based. So, yeah.
So yeah, basically we're gonna like teach you guys how to do the distillation, run instruments and stuff, and then probably at the end of this lab or quarter, we will teach you how to like synthesize certain chemicals and then like figure out the chemical characterization using all the instruments we have, like NMR, IR, and hopefully CC.
Yeah, our gas chromatograph is currently out of air.
I mean, it will be fine. Like we'll make it work.
Yeah, we're chilling. We're chilling.